Welcome to the Mapping Innovation Workshop. This is one of the series of about 16 or so workshops going on across the nation over the course of this week and next week. And basically what we're going to do is we're of course supplementing or building off of the Mapping Innovation Workshop series and a whole set of activities that were highlighted in the kickoff last week. So what we'd like to do today is provide a virtual workshop where we'll be discussing a particular application that we've been developing here, essentially testing the delivery of real-time biodiversity information through from across the entire data lifecycle, from data collection to data analysis, summary and synthesis, and storage, compliance, reviews, and then delivery through a variety of different tools, including web services, and also through our Biz tool. So I just wanted to check and see how folks are doing out there. You're unmuted. Can we hear from? No.
Hang on. When we unmute them, we get a lot of background noise. Okay, not great now.
We're getting some background noise. Maybe if you have, not sure what that might be. Sophia, let's see. We have who's on the line here. We've got Florence Thompson. Florence, can you hear us?
Hi, this is Florence.
Hi, thanks very much for joining us.
Sure, I'm happy to be here.
Great. Thanks. And Elaine Nakash, we have you, Elaine?
Hi, yeah. Can you hear me okay?
Yes, we can. It sounds real good. And then Kathy?
Yep, I'm right here.
Okay, sounds great. And we've got Lee right here in the room working on another computer, making sure that things are going well. So, all right. So just as a notification, we are recording this this presentation and the conversation. So just please be warned on that. Is there anybody else on the line though who I didn't mention? I think Leslie and Sophia are maybe going to try and join us, but maybe we'll kind of keep track of who's joining us and whatnot. And I'll see if I've heard from anybody. No. Okay. All right. So it looks like we might have a relatively small group, which is great. We will have a chance to run through this a little bit and then answer some questions. But before we get started, I'd like to go ahead and again introduce myself. I'm Jake Weltzien. I'm an ecologist with U.S. Geological Survey here, of course, in the Ecosystems Mission area. I have two hats I wear. One is the director of the National Phenology Network, and I work with my colleagues here at the University of Arizona. You'll meet some of those folks here today. And I'm also the program manager for the Status and Trends program of the Ecosystems Mission area. Status and Trends is about $20 million that is focused on the development and delivery of status and trends information with a particular focus on the biological component at a national scale. We fund the Breeding Bird Survey, the Bird Banding Laboratory, Great Lakes Deepwater Monitoring, now known as Deepwater Ecology, the Phenology Network, and a couple of other major programs. So what I'll do is I'll turn it over to Teresa Crimmins.
Hi, I'm Teresa Crimmins. I'm the Assistant Director here at the USA National Phenology Network, and I will be sharing with you today kind of a case study that we've been basically putting into practice here. The title of our presentation that we're going to start with a short presentation articulating what we've done and kind of giving that as an example of some work that we've undertaken and some of the challenges that we've faced in trying to put this into practice, and then hopefully that'll serve as a jumping off point for a conversation that is more broad. We also have...
Yes, I'm Lee Marsh. I'm the IT coordinator here at the NPN. I very much helped to set up and organize the technical aspects of the geospatial data that we're serving now, and happy to help answer questions in that regard.
Okay, great. Let's go to the phone then for introductions. So we see who you are, but maybe we can hear a little bit about you. You can introduce yourself. I'll start with Elaine.
Hi. There's an echo, so hopefully I'll do all right. I'm Elaine Nakash, biological tech at the Bird Banding Lab, and we are tasked with the USGS data release, and we have quite a large, unusual data set that we have one small visualization on our website, but working on many others, and I'm here to learn today.
Okay, that sounds great. Thank you. Okay, let's see. Yeah, Florence.
Hi, this is Florence Thompson at the Texas Water Science Center in Austin, Texas. And I'm a geographer here, and we just hosted one of these web mapping innovation workshops, and I'm listening in on all the others and participating. So thanks.
Cool. Thank you. Okay, and Kathy?
Hi, I'm Kathy Gerst. I'm based in Tucson with the USA National Phenology Network and University of Arizona. I'm a research scientist here, and I coordinate the delivery and development of our data products.
Okay, great, which has been a big focus of what we're doing here today and talking about today. Okay, so the general approach here is that we outlined, we'd like to start out with just a presentation. Teresa Crimmins is going to give the presentation, and what we'll do is it'll be relatively short, and we're just going to walk you through some of the work that we've been doing on the development and delivery of what I call real-time biodiversity information. Basically, plant animal activity across the U.S. is the focus of the Phenology Network, and in this case, we're talking about the delivery of national-scale gridded maps that describe a couple of sort of a climatological relationship with accumulated heating or warming, but we'll focus in today on a spring index, a map, sort of a threshold map of the onset of spring across the nation. And we'll walk you through a little bit of that and talk about some of our opportunities and challenges. The focus of the workshop will be largely on visualization, but we'll be touching on a number of other themes. And at the end, we'll open it up and probably focus in on 3 themes: data discovery and sharing, data understanding, and also communication and visualization. So we have about maybe 15 minutes to chat about, to walk you through this presentation so you have a better feeling as to how we're going about it, some of the challenges we're facing. Then we'll open it up for questions. Kathy Gerst is going to be taking notes here today, and I'll be sort of facilitating the conversation as we go forward. So with that, I'll go ahead and turn over to Teresa Crimmins.
Thanks, Jake. Okay, so as Jake just described, let's see if I can get my slides to advance. Oh dear. Okay, there we go. The case study that we'll be describing today is our recent experience with trying to create and release, share widely and openly, gridded maps or raster data of historical, real-time, and short-term forecasted products. And those maps are, as Jake already alluded to, maps that are updated daily based on incoming climate data that represent the products that we're producing as a function of gridded climate data that we're ingesting. Are daily maps of accumulated growing degree days, and also utilizing an algorithm called the spring index, and so giving updated daily maps of the progression of spring across the nation. So basically, what did we have to do in order to make that work? Our experience was to set up the IT infrastructure and then also to develop the workflow to be able to produce both those daily accumulated growing degree day maps. So when you see the abbreviation AGDD, that's what that's referring to. On 2 different base temperatures. We chose 0 degrees Celsius and 10 degrees Celsius because those are fairly standard base temperatures to use, and that translates to 32 or 50 degrees Fahrenheit. And then again, also utilizing this algorithm known as the spring index, which has been widely published on now. And what that does is it yields kind of a synthetic representation of the biological start of spring. Accumulated growing degree days are often used to predict or used by growers or pest managers because a lot of phenological transitions can be traced to accumulated temperature. However, it's a fairly large sledgehammer approach, and there are more nuances that can be integrated to predicting the timing of those events. And the spring index is one of those more nuanced approaches that integrates things like synthetic or synoptic heat events, so large-scale heat events in the spring, as well as day length. So it's a little more nuanced approach to representing the start of spring. And then finally, once we came up with that workflow to ingest the climate data, run nightly scripts to produce those maps, we then had to figure out ways to share those data out. And one of the major ways that we did that was by adapting the existing online visualization tools that we have to be able to display those daily gridded layers. So again, our technical approach, what the fundamental actual technical activities that we had to undertake to do this, was to set up a server on our side that could handle the geospatial data, and we opted to utilize GeoServer, and then to create and implement nightly processes that pull in the gridded temperature data that are produced on a daily basis by NOAA, and then apply those to our gridded layers, and then finally to make those available through our visualization tool, we had to work with the contractor, DJ Case, who had built the original visualization tool. So to just kind of quickly introduce you to what those layers actually look like, I'm just going to give you a static slide, but you can explore any of these through our online visualization tool or through any of the other access points that I'll mention in a second. What those maps look like, this is an example of one of those daily maps of accumulated growing degree days. This is one that's on the 32-degree base temperature, and it's July 1st from this past year. And so simply what it's showing you is how many growing degree day units have accumulated in every one of those pixels by July 1st of this year, starting on January 1st. These data are on 2.5 kilometer resolution, because that's what the incoming temperature data that we're utilizing is. Then we also make available a 30-year anomaly, a daily anomaly relative for that particular day, relative to that day of year averaged over the climate normal period, or basically 1981 to 2010. So this map shows how different was this July 1st from what's expected for July 1st based on the long-term average. And so this July 1st was actually way ahead of schedule in most parts of the country relative to that 1981 to 2010 average. So the darker colors the darker reds and orange are showing you where we were way ahead in terms of accumulating those growing degree units, and the cooler colors, the blues and greens, represent areas that were behind on temperature accumulation based on that day of year.
It's been a warm year.
Yes, at least as of July it was.
Yes.
I haven't looked to see where we're at now that it's almost September. And then the other suite of products that we have are those spring index products. And the units in these pixels are actually the day of year rather than a total growing degree unit. And how this works is that it's basically a bucket model where the pixel does not have a value until it reaches the requirements for the spring index, and then when it does meet those requirements and cross that threshold, the day that it meets those requirements is what is recorded. And so the pixels here, the colors represent what day of year that particular location met the requirements for either the leaf index or the bloom index. And in this case, we're looking at the leaf index. And again, what this really represents is when did we reach basically the biological start of spring. The leaf index is intended to represent leaf out in early season plants, in effect. And so that's useful in and of itself, but even more useful when you, again, can put it into context with the long-term time period. And so we also generate anomaly maps for these products as well, because it, again, gives you that indication as to, well, so what if I reached the spring index on May 4th? Is that early or late? And that's what the anomaly maps can tell you. And so this is the map for basically how spring played out for this leaf index in 2016, and the color, all the locations that are reddish in tone reached that spring index ahead of schedule, and so therefore spring came early, at the beginning of spring anyways, and the areas that are blue were where it was later than average. And so you can see there are some parts of the country where the start of spring was actually a couple of weeks later than average, but by and large, most of the country was a week or two early this past year relative to that climate normal period, again, 1981 to 2010. And then this is just a quick screen capture from the online visualization tool as to how you can interact with these data layers by just going to our website. You don't need to access them through a GIS if you're not comfortable with that. However, you can, but you can just as readily go onto the online web tool and through drop-down menus explore spatial patterns and temporal patterns in all of those variables. And then another really cool feature of the visualization tool is that you can layer on, you can explore patterns between the point data that individuals have been reporting through our online, or through our phenology observation program, Nature's Notebook, on top of the spring index layers as well. So in this particular screenshot, what we're showing is how is that start of spring, that spring index, how does that match up to when breaking leaf buds were reported for lilacs in 2016. And the point data and the gridded data underneath are being represented using the same color scale. And so if you see the same colors in the same locations, then that means that the modeled and the reported data were very much temporally aligned. And if you see differences in colors, then that means that there were some discrepancies in what was reported versus what was predicted. So it's kind of a neat opportunity to begin to explore what's going on with the data. And it's tricky to know when there's discrepancies what's going on, because neither can really be trusted as the absolute correct truth. So we're still having fun digging into that. Then kind of the underlying or the other important stuff is that we have metadata. We have FGDC compliant metadata to support all of these different gridded layers. They are developed and available through a GitHub repository and are also stored on our Geo server with all of the other gridded layers. And so if you are accessing the gridded layers through our web services, then all of that is readily available and right there as well. So now what I'm going to do is just kind of articulate some of the challenges that we've run into, not only in terms of developing these different data products, but then also in trying to share them out. Now that we have them, we've released them. I think it was in early May that we finally actually decided to go live. We felt comfortable with everything to the extent that we could share it as in provisional form with the public and everyone else. We're now faced with, okay, so we built it, who's going to come? So trying now to figure out how to make sure that the information is available to the potential users, and that it's not only that they are made known about it, but that it is in the appropriate formats and is as readily available as possible. So as Jake mentioned in his introduction, we're going to go through, I've organized these challenges in terms of 3 of the themes from the workshop, the Mapping Innovation Workshop framework. And so the first of those that we'll articulate quickly are data discovery and sharing. Then we'll talk about some of the data understanding challenges, and then finally communication and visualization. And these are all areas that we're very actively working on, struggling with and improving all the time. So first, specific to data discovery and sharing, basically, as I understand this theme, the challenge here is how are we making these data discoverable? And that's very much squarely a challenge that we are facing. We've had to really brainstorm actively within our team now that we've created these things. What the heck do we do? What are the activities that we need to do to undertake to make sure that they are discoverable and shareable? And so some of the activities that we have undertaken are to get them represented appropriately within Sciencebase, and we're also trying to make sure that they are beginning to get listed in other data repositories, at least the metadata, or other places where different user groups may go to learn about and discover new data sources. And we're still trying to figure out what the heck those should be, and then work our way into them. And then spreading the word as widely as possible. And that's pretty vague, but what we have tried to do is articulate all of the different potential user populations, and then begin to try and get onto their webinar schedules, try to work our way into their newsletters, actively advertise through our own webinars and newsletter series, go present at scientific conferences, and continue to just utilize as many of those communication mechanisms as possible. So we've done things like get this information posted on the LCC website, give webinars for National Park Service inventory and monitoring groups, work our way into invasive species and pest management group communications, presenting to agronomists and soil scientists, and just continuing to try and, turn over as many stones as we can on that front.
And LCC stands for Landscape Conservation Cooperative.
Thanks. And of course, some of the challenges that I'm sure you all are facing relative to this are, first of all, ensuring that we're truly reaching those audiences, and then secondly, making sure that the message that we're communicating is something that would resonate with them. So just as with any other kind of communication, trying to understand that audience as well as possible and meeting them on their turf. And so just a quick example of how we're trying to do that. This is a screenshot of the science-based entry for the Accumulated Growing Degree Day metadata. And so anybody who's comfortable with trolling ScienceBase to discover data could run across this because this is there now.
Yeah, one thing I might mention is you can see at the top there how there's a little the granularity, or the, what do you call it, breadcrumbs that allow you to see. We've actually created a page that's a community page or collections page within ScienceBase, and that allows us to describe other data sets that we deliver as well. So we're really happy with that particular functionality, and allows people to come and say, I want to know about what are the collections available through the Phenology Network. Oh, they have gridded growing degree days, they have gridded spring index, they have observational data, et cetera. So as we add additional data sets, we'll just be able to add them to the main page, and that provides links to these more detailed pages.
Then moving on to the second theme that's kind of a good organizing principle for kind of some of the challenges that we've run into. Data understanding is a big one that we're grappling with actively. We are definitely guided by the spectrum of trying to facilitate the transmission of data into information, and then helping potential users gain knowledge from that, and then eventually get to the wisdom stage. And so in that vein, we've undertaken, as I mentioned before, the activities like webinars, developing training materials that are appropriate for multiple and diverse audiences, definitely actively listening to users or potential users to better understand their particular needs, and then finally, also trying our best to document uncertainty wherever is possible. So definitely one of the ways that we feel like we can really help potential users feel as comfortable as possible with making use of these products is for them to understand what level of confidence that they can really place in these. Because, of course, gridded data right off the bat, any gridded data, is fraught with uncertainty. And then when you begin to take gridded data and do stuff with it, then it gets even more. You have multiple layers of that. And so what we're trying to do is understand as best as we can what those sources are and where we can quantify it, and then make that all readily available. Some of the challenges that we're running into along these lines is trying to work with many different potential audiences and user groups means that we've got a lot of different stuff to maintain and a lot of messages to keep abreast of, especially as we make enhancements or improvements to the tools or to the materials, and just trying to keep that all flowing. Not only do we have a diversity of communications materials and training materials, but then we have multiple data access points too. So we, as I mentioned and sort of pointed out before, we have the online visualization tool. However, if you're more savvy, you can access all these gridded layers through our web services. And we, after having launched all of this, began to recognize that there was a need for an additional way to access the data because of some of our users were comfortable with either one of those. The Viz tool wasn't quite meeting their needs because they wanted something more specific, but the APIs or the web services were too difficult, and so our programmers came up with a really cool intermediate interface where you can basically access a website that will help you, or a web page on our site that will help you build the query request, and it will dump out the map that you're looking for. And so that was an example of trying to work with diverse audiences and listen to them and meet their needs actively. Going back to documenting the uncertainty, one of the things that we've done in an attempt to be as transparent as possible is where it's possible to actually quantify this, we do so. And so for our Accumulated Growing Degree Day products, what we do is compare our daily accumulation data to an independent source, and in this case we compare the values at particular locations to those being generated from climate reference network stations, which are not used in the production of the temperature data that are what we build our own products from. So they're independent, and they're considered the gold standard. They were put up several years ago by NOAA to be kind of the gold standard and for verification for all of their own products. And so what we have here is a tool that's on our website that enables you to look at by climate reference network station, which is what these points are on these two maps. How does the daily accumulation of temperature as calculated based on a climate reference network station compare to what's being calculated and reported through our products? And so the maps above enables you to look at that variation by date through a little slider bar at the top. And then if you want to drill down and look at how those accumulations vary by station, that's what the lower temporal trace plots show you. And then finally, going into some of the communication and visualization challenges that we have faced. Again, just trying to work with as many different people as we can as possible, and keep diverse and ongoing communications are what our main activities are. Some of the challenges that we've really run into include finding that after daylighting some of this stuff, we have done a really nice job on some fronts, but that there are some really obvious improvements that we could make to make things more logical for potential end users. And really just understanding the ways in which folks will access and use this is key and fundamental and ongoing. And a really good example of that is with the accumulated growing degree day product. Again, what we found was, so we make these daily maps of the accumulated temperature available, and that is fantastic. But when you go to try to actually make a decision based on it, it's a little awkward with the way our system is set up. It's not impossible, but if you were to rely on the visualization tool, it can be a little challenging. And so a good example of that is in the case of the Western tent caterpillar. It's been documented clearly that these guys are active when accumulated growing degree days based on a 50 degree base temperature are active between 100 and 500 units. And so you really want to know, if you're going to be a pest manager who wants to go out and spread pesticides, you want to be doing that when the AGDD's accumulation is between 100 and 500. There's no point in doing it before 100 because they're not active yet, and after 500 they've already turned into the moths or whatever they turn into, and they are not susceptible to the kind of sprays that are most effective for the larva. So here's an example of a map for where you might expect to see Western tent caterpillars on May 16th this past year. And we can look at it and we can just kind of guess at, okay, well, where should I be spraying on the ground? Where are we seeing things between 100 and 500? And this is basically what you would see if you were to go try to explore these data through our Viz tool. What would really be handy is if you could just mask it and say, I want to know what are all the locations that meet that criteria that are between 100 and 500 growing degree days today based on this data set. And so that's what I'm showing here in gray. And that's an enhancement that we are working on trying to put into functionality to get going sooner than later, because it's a fairly simple thing that would really make things much more usable, we think. And so, to summarize our activities here, where we are at now is that we are in the final stages of preparing a techniques and methods report that document what all these data products, these gridded data products are, and how we are generating them, and that is in the final stages of FSP review, so should be published relatively soon, we hope. And the same thing for the data products themselves. They are almost through the FSP review process now. And then the next step for us will be to prepare an open file report that will describe at kind of a higher level what the process for us has been to create these dynamic gridded products and then get them through FSP review and publish and release them through USGS and kind of outside the USGS and do all that so that other entities who might want to follow suit and do a similar process with publishing and sharing data within USGS can benefit from what we've learned through this experience.
And maybe I can just mention that, of course, essentially the first two bullets and the production of these was funded largely by the Community for Data Integration we got a grant this year for FY16 to essentially work with the development of these products as a case study, but then document the process for essentially real-time delivery of dynamic data sets from a biodiversity perspective, which there aren't a whole lot of models within USGS. So that's the idea with the TNM report and the open file report. We can apply that to other projects. One more bullet.
Sure, yeah, that's okay. The final activity will be simply to keep on doing what we're doing, which is developing and improving those training materials and those communications to the various users groups. So at this point, we thought we would take questions if you have any questions specifically about what we did and how we did it, and then after that we can move on to the broader conversation about the challenges that you all might have faced as well.
People are off mute.
I believe so.
Let's make sure that they're off mute.
I've got a couple questions. This is Florence in Austin, Texas.
Hi, Florence. Please go ahead.
Let's see. So the first one is how much new data are you having to deal with every day, and is that automated or manual? Yeah, that's the first one.
Okay, good question. Lee Marsh.
Trying to get specific numbers off the top of my head. I don't know if that's more interesting or... Anyways, the contemporary data files, I think there's about a dozen different layers. So for each one of those, we're going to be generating a new file each day. Actually, what we have in place is a system that sort of looks to the future. So there's NDFD data, which is forecast for the next 6 days. So we're actually ingesting the next 6 days plus the previous 3 days data because they're updating that model every day, sort of pushing that through our system and generating our maps. And like I said, I think there's about a dozen altogether. And that whole process is automated. We've got Python scripts to just grab that data from the remote servers, process it on our system, and it's automatically pushed out through the GeoServer.
You are also developing, you have a script that adjusts the grid sizes because your historical data that you're using as the base
get
adjusted.
So right, for the anomaly maps, we've got these 30-year averages, and we basically had to reinterpolate those from 4 kilometers to 2.5 kilometers. But that's not something that actually happens on a nightly basis, though.
Okay.
That's basically just, we're using PRISM data for the historic records and this NDFD data for the contemporary. So one's at 4 kilometers, the other's at 2.5. So just as a necessity of making the two comparable, adjusting the historic data to 2.5K resolution.
That's all done via services. And we didn't really describe it, Florence, necessarily, but the way I like to talk about it is that we basically serve up data from 1981 through 6 days from now into the future. And so since the daily data are produced and modified by their essentially weather service forecasts, and they're modified each day as they get better from the weather service, we ingest those modifications, and that's why we run it every night.
Okay. So is this is all of that downloadable, like any given date? Could I download data?
So for the contemporary stuff, you can get daily data. And for the, well, let me think. There's so many products, it's hard to keep it all straight at the top of my head.
Yeah.
The accumulated growing degree day data are just daily data for 2016.
Right.
Anything previous to that is all we have available is the long-term average for each day of year.
Okay.
That would be a correct statement. And for the spring index historic records, there's separate files for each year. As Teresa kind of described it as a bucket model, it's not really helpful to have daily.
New one for each day.
Right, exactly.
For the historical data set, but we are producing this spring index for each day of the year now.
Right. So also all this said, we do have each of these data layers described in some documentation files that we have available, and that gives attributes about spatial and temporal resolution to each of the products that we have available.
Okay.
So yeah, so if we get questions or requests from scientists, for example, maybe you're kind of hinting at this, that, oh, I need to have growing degree day data on a daily basis back in 1994 through 97, because that's when I was looking at emerald ash borer or whatever, or fires in Bastrop, then we would be able to get those, but we don't necessarily hold those right now. Really, the idea is more to develop the workflow, produce these, and then hear from people what they need for their science applications.
Okay. Thanks. Could I ask another couple questions, or?
Yeah, go for it.
Okay. I'll just ask both of them right away. Let's see. So one of them is, where are you hosting it? Is this? I see it's a .org. Is that at the university or just your own separate? I don't know. Well, I'm wondering where you host it. And then the second one is, are you using web analytics, like something like Google Analytics, to look at who's using the site or downloading the data or something?
So we're hosting the data on our own physical infrastructure, and that's hosted here at the University of Arizona. So they manage the physical infrastructure needs for our servers. And we have enough disk space and computational resources to handle everything that we're doing at this point. We have sort of been exploring the idea of using either Amazon Web Services to host or process data, or alternatively, there's Cyverse. I don't know if you're familiar with that, but it's sort of like, well, I don't want to say it's a worse version of Amazon Web Services, because that's not totally accurate.
This is being recorded.
Yeah. But it's like Amazon Web Services that is available for researchers, and they make available for free computational and CPU processes, memory, and disk space. So you can store files, process files there. But that's just something that we've been kind of exploring in a preliminary sort of way at this point. In terms of web analytics, to my knowledge, there's really no easy way to sort of like integrate the hosting of the geospatial data with Google Analytics, which would obviously be the best choice because they have available these really sophisticated tools for looking at how people are using and accessing the data. However, I have kind of taken a step back in time, and I've installed a module on the server, on the GeoServer, AWStats, and it's basically a tool that analyzes your Apache logs, and you can see, approximately how often the server is having requests being made to it, and generally like which regions. So it's looking at IP addresses to see if it's coming from like a campus network or a government agency or something like that.
Okay. All right, thanks. I'm exploring the visualization tool while you're doing your presentation.
Oh, excellent. Yeah. Just to clarify too, the U.S. Geological Survey funds the activities of the National Phenology Network, but the operations of the network are coordinated through the University of Arizona by a cooperative agreement between USGS and the University of Arizona. So we're running the .org, but it's major funding from U.S. Geological Survey. It's hosted here at the University of Arizona.
Okay, thank you.
Any other questions about sort of what we've heard so far in terms of the tool itself, and then we'll just change gears in a moment to just talk a little bit about do a little bit of elicitation from y'all in terms of the themes for the workshop, so we can kind of be consistent with the other themes. So, any more talked about so far?
This is Elaine in Maryland. I have a quick question about your what was it, GeoServer platform?
GeoServer?
GeoServer. Why didn't you go with S3 products?
Good question.
It's a great question. We anticipated that one.
Yeah, Well, I kind of have to tell like a story about it to really answer your question, and it starts with the fact that we already had a GeoServer instance running for a separate project, and we really hadn't used it for very much or used it in any sort of sophisticated way, but it was there, it was active. So we started like our preliminary exploratory work with that. At that point, we started kind of running into some walls, usability issues, documentation issues with GeoServer, and kind of started to doubt that decision. So we consulted some GIS experts that we have professional relations with here at the university to get sort of their opinion on Esri versus GeoServer. And sort of the short answer that we got from them is, you know, it doesn't really matter. Like both of these product suites are able to do whatever it is that you want to do, and they're both pretty good tools. We were also able to get some technical assistance from those same individuals in terms of surmounting the issues that we were having with GeoServer. And at the same time, we kind of started to do exploration of Esri and seeing if it would suit our needs. And kind of what we found was that we were already, you know, waist deep in GeoServer. We were getting these GIS experts that we were working with to kind of affirm that it was a quality product, and having more difficulties with Esri. We got the license from free through the university, but the documentation for Esri is sort of limited to if you don't have any training. And nobody in our office had familiarity with that tool suite, and we just didn't see it as a necessity to invest in training to use Esri.
And you see it as a good solution.
Check it out, GeoServer. So that's sort of like the evolution of how we came to use GeoServer.
And you see it as a good, as good for the long term?
Yeah, we've run into a few complications. I won't say that it's been totally pain-free. The documentation is pretty dicey for GeoServer, and we've had a few technical issues that we still haven't been able to surmount, but overall we found it very easy to use and work with, and it's been able to handle everything that we needed it to do up until this point, so we're pretty happy with it.
Thanks.
Can I ask a question, maybe, Lee, and show my ignorance about open innovation and open access, essentially? So we're getting a lot of top-down requirements to do open access, follow certain standards like OGC, Open Geospatial Consortium, and et cetera. And GeoServer is essentially an open product, but would you call Esri necessarily a closed product?
Well, GeoServer is open in the sense that the software is free and anyone can contribute to the code base. Okay. Esri costs money. It's a enterprise corporate product, and it's quite expensive if you don't have the luxury of the licenses that we had made available through the university. That said, they're both implementations of the OGC standards, which means they both adhere to the the standards for geospatial web services.
Okay. Okay. Great. Okay, that helps. Thank you.
Also, as long as we're talking about, there are other alternatives too. We haven't really explored those as well, but I have other geospatial friends that have used things like MapServer. So if it's something where you're looking at different options like that, you're not limited to just Esri or GeoServer. There's other stuff out there too.
Yeah. And I'm not well enough familiar with the relationship between USGS and Esri, but I think that it's very close.
Quite cozy.
Yes. Okay. Any other questions about some of the content or discussions so far? Okay. And maybe just before we switch gears, one thing I'll point out too is that we sort of skipped a big part of how we sort of collect the data to develop the algorithms to apply to the climatological models, et cetera. That's fodder for another conversation, but we use professionals and volunteer geographic information, essentially VGI or citizen scientists, to help collect phenological data that we use to build and parameterize models. And that's what we'll be doing as we go forward. So this is really just a workflow with this Spring Index product, for example, that will enable us to plug in and develop species-specific models and deliver the information in the same way. So we turn that information back around right to our volunteers who collect the data in their backyard and they'll be getting real-time reports of model prediction, model forecast, short-term forecasts that enable them to make decisions about, do I spray today? Do I go out and do my invasive species surveys? Do I go out and do my monitoring today? My red maple is supposed to come out sometime this week. I should go out and check and just see how bad the NPN model is. Oh, it's actually pretty bad. But then we can say, okay, well, that's where we need to get more data, or pretty good. So there's a lot of work to do kind of across the entire data life cycle as we go forward. Okay, so shifting gears a little bit then to the next section, where we thought we'd just try to do a little bit more elicitation from you, and this is where Kathy Gerst will be taking notes. What we decided to do here is focus on just 3 themes from the set of themes described by Mike Tischler and Sophia Liu on the workshop framework. 3 different themes: data discovery and sharing, data understanding, and communication and visualization. And really what I'd like to do is use this time as a USGS program manager, but also someone who's very, very interested in working across missions and programs and thinking a lot about data management and delivery, and especially essentially moving towards real-time delivery of biodiversity information. I would like to hear from you all what ideas or thoughts or comments or contributions you might have that we can capture in our report to contribute back up to the organizers of the workshop series. So what I've done is said, okay, let's just put up the questions that were sort of gleaned from the earlier comments. I think this is Sophia and Mike putting these together within the theme. So right now you can see the data discovery and sharing theme. And so there's some questions for you. How are you sharing your data? How are you making your data discoverable? Are your users finding the information? How are you dealing with large geospatial data? I know that the BBL, for example, has a lot of information, as Elaine mentioned, and sometimes it's kind of a little tricky. And how are you dealing with this? So we might spend there's 3 slides, each of which has a little set of questions. We might spend 5 or up to 10 minutes as necessary per each one of these 3 slides. And these are just brainstorming questions for you. Whatever you'd like to contribute would be great. So again, I'll open up the floor again for folks who might have some comments.
Well, as far as BBO goes, we're serving data through Bison. And it's a subset of what we have available. It's basically the occurrence records for birds that have been banded going back to 1960. And we've provided about 20 million records to Bison.
Okay. Okay, Elaine, thanks. So just to summarize, so you've produced for the bird banding laboratory. You have reports where people are finding banded birds. You're managing those data and then delivering them out through Bison, Biodiversity Information Serving Our Nation, which is run out of CSAS, Ecoscience Synthesis Branch, and about 20 million records, and there's basically occurrence information. Is that right?
Correct.
Of a dead bird, or probably mostly dead birds?
Many of them are dead by now, but they were alive at the time of banding.
Oh, at the time of banding. Okay, because you also have a reporting hotline for reports of where people found the birds.
We do. We haven't actually provided the recovery or encounter data yet, but they're working on that.
Okay, so this is the data set that's delivered through Bison. Just so I can clarify, the data set delivered through Bison is where the birds were actually banded. So they have good information, probably a fair amount of information about each organism, each
Well, it's
record.
actually pretty limited. It's species, date, and our resolution is the 10-minute block. So that's approximately a 10-mile by 10-mile, depending on the latitude, area. So it's a bit generalized. It's not the exact location.
Oh, is this on purpose?
Well, that's the history of BBL. The data was only collected to that that level that's in the database. We have more details on locations, but it's all on paper still.
Okay.
It's being scanned now, but
Okay.
and it would be a great citizen science project to have folks digitize that.
Crowdsourcing, yeah. Yeah. So
But
20
I do
million
also have a concern about sensitive species and at what resolution you provide locations.
Okay. So can I ask, so can you tell us a bit about the process for sharing those data back over to Bison? You've got 20 million records. That's a lot. How does that work?
Oh gosh. We have an Oracle database and an Oracle DBA, and she runs a query, and a huge CSV file is provided to CSAS, and they upload it or massage it. They add their own columns in addition to the fields that we provide.
Okay, so you provide a flat file, probably probably segmented by years or so, and then they add maybe a unique identifier or a data set identifier somehow, and then show the point locations out through the Bison interface. UI. Okay.
That was the thing I was curious about, is if Bison had some interface or mechanism for visualizing so many records in a meaningful way and a geospatial way.
They have a pretty nice user interface.
Yeah.
Pretty nice map, and I think you can search by text. I'm not sure whether you can search by guilds or could you search by data set. So for example, if you wanted to get all the BBL observations,
yeah, you can do that.
You could show them all.
Filter by provider.
Filter by provider. Okay, great. And so one thing we've been working really hard on here and really focusing on and emphasizing is the development of web services as a way to move data, to kind of meet the requirements for machine readability, and open data sharing and et cetera. And so my understanding is that you're using a flat file to provide data over to Bison. And how have you investigated the possibility of using services?
Yes. Do you know Yassine?
Yassine? Yes.
He's a fellow who's programming here, and I guess some of the folks have an Amazon subscription, and I don't know how the details of how they're putting it together, but there is a move toward a more direct connection to a version of our database.
Okay, great. Just kind of along the lines of the theme of the workshop then, so challenges and opportunities, you see the use of services as a real opportunity perhaps that we should continue to pursue, not only for your project but across your center and maybe even USGS?
Absolutely.
I didn't mean to put all the words in your mouth there. Sorry. Okay. How about challenges though, related to that little case study we just talked about?
Well, you talked about reaching out to the diverse audiences, like inventory monitoring, all the Park Service initiatives, and I would hope to see some standardization of the attributes across the different data sets. Do you see that happening? So everybody's developing these fabulous products, and we all have our own angle on the data that's being collected, but it sure would be nice to see a standard format to provide information, what I'm trying to say.
Yeah. So to promote interoperability and data integration eventually.
Right.
Okay. And you're concerned that there might be issues with that, with attributes or because of the way either you're delivering the data might be different than the way somebody else is delivering the data. Does just one little detailed question, is Bison forcing you to follow any particular format, or are they just taking it however you give it to them and then they fix it?
They're not forcing us into anything. It is a real caricature of the BBL data, though. It's very limited. We're not even providing age and sex or anything. Our species, quote unquote, which sometimes are subspecies, or intergrades or unidentified teal or junco, some group of similar species. They are giving the IDIS number. We have to force ourselves into the different
IDIS framework. Okay. Okay. Yeah, that should facilitate things, because we also use IDIS here at the Phenology Network, for example, for standardization.
That's an example of standardization that I think is great across the different data sets.
So one challenge that comes to mind that I think anybody who's exploring the use of APIs could run into is, if you've got the ability to connect to somebody's data source really quickly, there's that temptation to want to share out more and data that's like more recent, I guess. And that's what we're trying to do. One of the things we're trying to do here is share out what we are doing, is not only making available historical data, but data predictions of, or accumulations of growing degree days and of the onset of spring as it's happening, and even on a short-term forecast. But then suddenly you're running into a situation where this is provisional at best. You know, there's no way to have it be carefully reviewed if it hasn't even happened yet. If you're making a forecast. And it seems like that challenge could extend to a lot of programs if they're beginning to think about wanting to have data more readily available and closer to real time as it's being collected, instead of it being the situation where it's a very static, concrete, thoroughly reviewed kind of file that doesn't change.
So the BBL is kind of like that, because they've got the data that's sort of static back into the 1960s or so, and they're tracking the species of identifiers through time and have chances to apply QA/QC however they do. So
yeah, although I mean, the situation that we're facing could extend to them or others too, where as reports are coming in, it would be possible to make those available right away, rather than waiting until everything's been super QA/QC checked and cleaned before revealing it. So,
good point. Any other questions or comments on the data discovery and sharing theme, Florence?
Oh, I guess I could add a little bit. It's kind of outside my scope of work, because it's a lot of what some other people in my office are doing. But we're one of the things that we've been doing recently is we created this water dashboard and published that in April. And it lets people see real-time stream gauges and all sorts of weather information like radar and precipitation forecast and precipitation history. And it's also connected to the National Weather Service, so we can show what streams are flooding. And then the big thing, well, new for us, is that we added Twitter feeds, so that we're bringing out real-time data for gauges that are above flood stage or just about below flood stage. And then also Twitter feeds for precipitation that's above a certain intensity, I guess. That said, it's other people in my office that are doing that, but it's a new way that we're making our data available.
Okay, through these dynamic dashboards where people can go and find data, and this is for Texas, or is it a subset?
Yeah, this one's for Texas. So it's an interactive map combined with a Twitter feed on the side.
Okay, that's cool.
Do you feel like promoting that through Twitter has been helpful in engaging people and getting people interested in communicating about it, or?
I think so. We have our web, one of our web developers in the office does a lot of work on web analytics. We use Google Analytics for something. She uses Crazy Egg to find out where people are hovering or pointing or clicking on the website. And she also looks at the Twitter feeds and has made some maps showing like what's getting tweeted, what's getting viewed, and then what's getting shared. I'm not a Twitter user myself, but she's watching that. And we've gotten some, trying to think where we've gotten kind of, I guess, advertising. We did a USGS top story or news release, and then I believe Twitter actually put out a story. I don't know where they did that. It was more than 140 characters. Daniel Pearson is really the one. He's our supervisor for our group, who's spearheaded that project and would have a lot of information on publicity and things like that. We also got publicity from some of the local TV news stations and weather people, and he did a few interviews for them. And so there's, I guess if you're, he's a good person to contact to get information about kind of getting the word out. I think there's also, we're dealing with different kind of data. We're dealing with rainfall and or precipitation and flooding, and so there are a lot of people that are really interested in it for a period of time, and then it kind of tapers off. And then when we have another series of events, people become interested in it again. So I don't know if it would have the same, it might have kind of a different cycle than the phenology data or something like that. But I think that they might have some good insight, both Daniel and then our web developer who monitors web analytics could have some insight on spreading the word.
How close to real time is the data that you're working with and sharing outwards?
It's the same as the NWIS web services, the real-time stream gauges. And I think it varies depending on how active they are. I want to say 5 or 10 or 15 minutes in some cases.
Oh.
Yeah, the water information system is certainly like the gold standard for real-time information delivery within USGS, and I think we could probably learn quite a bit by going over and working with those folks a little bit more. Not just here. I like the idea of Twitter. It sounds like they're essentially automated Twitter notifications, so like push notifications using Twitter as your platform for giving people information like you can't cross your stream crossing down there by the Guadalupe River.
Yeah, sort of, yeah. Which might, I mean, it's kind of a, well, yeah.
Or would that it could be quite that way where you could have that. Okay, because a lot of flooding in Texas gets hit hard over and over again.
Yeah, we do.
Yeah.
And if it's not raining, then we're in the middle of a drought. So.
For fire. That's a tough, Austin. Okay, great. Thank you so much for your comments. Before we just change this slide real quick to the next theme, I see we've been joined by Rebecca Smith. Rebecca, if you would like to introduce yourself and maybe give us a bit of context as to what your interests are and any contributions you'd like to make at this time, that'd be lovely. If you're talking, Rebecca, we can't hear you. Okay. All right. Well, let's go ahead and then move on to the next theme slide with a set of kind of canned questions that were provided by the workshop organizers. Again, these are just conversation starters. If we're thinking about data understanding, we've talked actually a little bit about that, but we haven't talked a lot about science questions and how do we move from data and information. What are you, with all of these technologies that we're talking about, what can we either as society or researchers discover from sharing geospatial data? Are there needs for methods or processes or models or architectures that we don't have that we should be thinking about to improve our understanding of data? And are there chances for integration with other kinds of data that could be leveraged? So any opportunities or challenges anybody would like to share that would, thinking from your own project to what should USGS be thinking about from an enterprise perspective, or anything like that? And again, we'll capture these and report these back up to the workshop organizers, our report. Thoughts? So maybe Florence, can I put you on the spot and just kind of revisit one thing we kind of started talking about on the last slide, and that was stream gauge or delivery of water information and flooding information at points. What it sounded to me like when I mentioned that, sort of like, oh yeah, you could get a Twitter feed that you can't cross the stream crossing on Farm to Market Road 4939. And for example, what's keeping you from doing that? Or maybe that's not a good thing. I don't know. What do you think?
Oh, let's see. Well, we don't actually deal with low water crossings. So what's keeping us from doing it?
Or is that a good idea? Is low water crossings a good idea? Meaning low water crossings, meaning like, well, what I guess I don't even know what that is. What is the low water crossing?
Oh, sorry. A lot of times the creeks are dry, and so the roads go right across them, or just have a couple of culverts under the road. It's not actually a bridge. And when it does rain, they flood, and so you can't drive across them.
Yeah.
So I don't know if that's an area that we would really want to get into, since we're not, since we'd want to focus on the actual stream gauge data. And then we're bringing in the National Weather Service flood forecast. So we're reporting, what the stage is and CFS, and using other tools for like predictive gauge height and things like that.
Okay. So Don Klein, the AD for water, just recently sent out a note to USGS highlighting the new national water model that's been developed actually out of the Weather Service. And he argued in his email that we should be, he said NOAA is the agency that's getting the credit in the lead of the story and the story headline. And he said, I'll have to see USGS in the next big story that comes out. And he was sort of setting a challenge, a little bit of a shot across the bow to USGS and the water missionary to be thinking about, okay, how are we delivering water information? And so one could say, okay, well, yeah, it would be really good probably to have low water crossings and notifications of that for lives and property. Not to put you too much on the spot, but is that, what do you think about that? Would that be something we might consider as an agency, or is that going to be somebody else's purview?
Yeah, I don't know what I could add to that. I don't know. Sorry.
Okay, that's right. Okay, that's cool. All right. I went to school in College Station.
All right.
And now it's driving out to, Enchanted Rock State Park. There's a lot of low water crossings as you go out there across the Edwards Plateau, and wow, it'd be kind of cool to know whether or not you could make it, or whether you'd have to go through Fredericksburg, or could you go through Llano, et cetera. Anyway, that's some of my favorite country. All right, moving on. Rebecca, were you able to get in touch with Rebecca?
We're having trouble with her audio, so I think she may share comments through the chat, and I can read them out.
Okay. Or she, is it possible also she could call in on the telephone number?
We were sort of trying to troubleshoot. We were not successful.
Okay. Rebecca, if you have a comment or anything like that you'd like to share through the window, that would be lovely. Okay. Any other comments or on this particular theme, especially related to challenges for data understanding? We know to wait for 7 seconds. That probably wasn't quite 7 seconds. Oh.
Oh no, sorry. We're still just having trouble.
Okay. All right. Well, let's go then to our third and essentially last slide that deals with again one of the themes from the workshop series, and that is communication and visualization. So we've talked a lot about that already. I think Teresa gave some really nice examples of how we're sort of visualizing the data in this interactive viewer, communicating the data in different ways. And I'm wondering if other folks have anything they would like to contribute. So, for example, Florence mentioned this dashboard. Sounds kind of interesting as perhaps a way to get people involved. And how are you letting people know about this? And what would you do differently? How about getting the information out to decision makers and public consumers? Does BBL data need to be delivered through, is the public needing information, or is Fish and Wildlife Service getting information from the bison viewer? And are there any sort of things we should think about where data ought to be stored to be able to be delivered that way?
Right. We're still in the early development of all this, and the Fish and Wildlife Service is a big user of the data for establishing regulations for harvest rates and everything each year, and that data is carefully crafted by staff at BBL and handed off to them, and this probably hasn't been done for a while.
Yeah, so you do a fair amount, Elaine. You do a fair amount of processing of the BBL records to hand over to Fish and Wildlife Service on an annual basis, say every January or February, something like that.
Well, there are a couple of products, Allbirds and Game Birds. That's a FileMaker Pro based view of the data. It's a data set that goes out on CD. Things go way back.
Okay.
And they're updated every 6 months.
Okay. So I use FileMaker Pro as a way to manage the data and or build visualizations and then send kind of a report out via a CD to the migratory birds or game bird section of Fish and Wildlife Service?
Right. And there's some sort of map viewer that's associated with it, but it's pretty crude. And I use desktop ArcGIS, and we'll produce KMLs or shapefiles for folks on an ad hoc basis, but we don't have anything formal.
Is Bison kind of like one option for just sharing the raw data back out? Because it sounds like you're producing synthesized data on your desktop, but then Bison is for the raw data and making it more accessible to everybody else.
So we're working on that right now. It's the Oracle database is a complex beast, and everything is derived from it. Nothing original comes out of it. It probably doesn't make sense, but we have an application in-house for running our queries and reports, and it's pretty limited. And the one person who has built the entire database, I think, is the only individual who understands the
Okay, this is someone who's writing your queries for the Oracle database?
Yeah, and I try to get in by running SQL queries directly onto the database, but I can't even see everything that's in there. So
Yeah.
I really am not sure what it looks like in its raw form.
Lee, would you like to comment?
Just that we use Postgres SQL for managing all our geospatial data, and it can definitely be challenging to get anything meaningful out of that, especially if you're querying geospatial data, because when it's sort of serialized in a database, it's not something that you can just quickly and easily scan with your eyes.
What kind of enterprise solutions have you set up then to be able to deal with and interface with the data set that way, Lee?
That's really, that's the purpose of GeoServer. So, it communicates with the Postgres database. That's actually where we store all the data files, and so it's able to take those serialized raster data files and serve them out in whichever format is suitable for the end user.
Do you have a library of queries that you store somewhere as well?
In the rare cases where we've needed to do something, querying the database for some specific data, that's been something that's been very rare. We haven't really had to do it as of yet. And in fact, the web WCS services, web coverage service that is, provides different ways of querying that data, so you don't have to deal with the database directly.
Early on, I know we were querying the database directly.
What do you mean by early on? Is it
before you came?
Oh. Well, that's the MySQL database. That's like that's the point data, the in situ observations, and that's much more easy to work with. MySQL, I think, is better documented and a little more accessible. But I would say that DBA that you have for the Oracle database, if that's the only person that can or has the knowledge base to query the database, you better take very good care of her.
Yes. So person do.
Okay, yeah. So it sounds like if I was to try to encapsulate that as a challenge for our report, it sounds like how would you say that? What would be the challenge that sort of Elaine is facing with this ability to?
I don't know. I think. I don't want to put words in Elaine's mouth, but it sounds like in all of these organizations, it's hard to find good help, especially as the technology behind the solutions gets more and more sophisticated.
Yeah, I guess there's a balance between the security of the actual records and access to them. That's the challenge here.
Okay. Okay, yeah, good. I think as we get more and more data, and you're right, as the systems change, it seems like we're always upgrading something. You're always upgrading.
Leave it to me. That's the thing. We had to expand our internal sort of knowledge base pretty extensively prior to, this time a year ago, we were just started sticking our toes in the water in terms of GIS capabilities. And we've been really fortunate enough to have hired some really intelligent people to sort of help see this through.
So I wanted to take the opportunity to introduce Rebecca for herself because she's unable to join the audio. She took the time to write that she's a student intern in Reston. Her internship is mostly based on using Esri products, and she's been attending these webinars or workshops to get more knowledge on what USGS is doing nationwide, not just headquarters. She doesn't have questions, but she is enjoying listening to the comments.
Okay, great. And Rebecca, if you would let us know, chat us as to where you are in Reston. Are you in what mission area or office are you sitting in when you get a chance? Okay. Any other comments on communication or visualization?
She works with Roger Sayer in the land use science. Land change science.
Land change science. Okay, thanks. Okay, great. Roger has been really involved in a lot of geospatial work, and they're doing some pretty cool things. One thing I would like to just point out to folks is that there's some very nice the kickoff presentation. All of the presentations are up now online, and you can see those slides. And there was a number of really cool cool projects and products that were highlighted there, including this land change mapper. I don't know exactly what that's called, but Rebecca probably would remember what that was called. And it looks like it's a really cool, cool tool to basically work with tiled, basically, or gridded tiled data from Landsat and integrate it with land cover stuff. I'd love to introduce you guys. It's quite good stuff. All right, let's see. I guess what I'll do is just open it up to say I think we'll probably go ahead and shut it down. I think we've had lots of really good comments, lots of good questions, a good conversation. Unless there's any burning last questions, I think we'll go ahead and wrap it up.
Thank you all for sharing your experience.
Thank you, too, for sharing your challenges and just joining in this conversation.
Great. Thank you, everybody. And what else? Next steps here then are we have a template that we're using for reporting. Kathy's been taking notes. We've got the names. Anybody else, in case anybody else, did anybody else join who we didn't have the name?
They're all here.
We're all here, okay. Because we'll capture that. And we'll put together a report from this conversation into the template, and we'll get that posted. I think along with that, we'll have our slides posted and links to some of our other products. So with that, thank you so much, everybody.
Jay, this is Kathy. Can I ask a quick question?
Yes.
For the notes, I don't know if I got everyone's last name correct. Did Teresa or you write down
Yep,
last?
we got it.
Okay, great.
We're good.
Okay.
We've got it.
Sounds good.
Okay, thanks. Thanks, everybody, for joining us. Really appreciate it. It was fun.
Thank you.
Take care.